Section 1.7, we're going to be talking about combinations of functions and composite functions. We're going to start out talking about the domain of a function. Okay, we've already said that the domain is the set of the x values that are associated with a relation. Here we say the domain of a function is the largest set of real numbers for which the value of f of x is a real number. Exclude from a function's domain real numbers that cause division by 0 and real numbers that result in an even root of a negative number. Okay, so for your examples, it says to find the domain of each function. If you have a function that does not contain a fraction where you have a variable in the denominator, or it does not contain a square root or an even root, then you do not have any restrictions on your domain. Okay, we can say that x can be any value. I can put any value I want to in here for x and be able to get a value for the function. So we say the domain is all real numbers. To write that in interval notation, it would be from negative infinity to positive infinity. Okay, if they want it written in interval notation, this is how you would type it. On part B, you have a function that's a fraction. This is where you're going to have to exclude values of x that would make the denominator be 0. So what you can do is take your equation that's in the denominator and say we do not want that to be 0. Okay, we don't want the denominator to be 0. If I solve that for x, this means x cannot equal positive 3. So let me show you two ways you can write it. Set notation would be the set of all x such that x is an element of the real numbers. Okay, and then we have to put and x cannot equal 3. As far as interval notation, we would say that x could be anything from negative infinity up to 3, parenthesis to show that it does not include 3, union, parenthesis 3 to positive infinity. This just means it goes up to 3, skips over 3, and then can be anything above 3. And this is how you would write it in interval notation. Okay, on C, you would also have to look at your denominator. Okay, remember it doesn't matter if the numerator is 0. Only the denominator can't be 0. So again, I would take this equation or this expression and say we do not want this to be 0. If you have a quadratic, you're going to have to factor. Okay, remember factoring, opposite of full. What's going to multiply to be negative 3 would be 3 and 1. Subtract to give me negative 1 would be a negative 3 and a positive 1. And then we would set each of those not equal to 0. So this means x could not equal 3 and x could not equal negative 1. Those are the only two numbers that we need to exclude from our domain. So again, set notation. X is a set of all numbers such that x is an element of the reals, that x cannot equal 3, x cannot equal negative 1. Okay, that's set notation. Interval notation, we would say x could be anything from negative infinity up to negative 1. We would skip over negative 1 and go up to 3, skip 3, and go to positive infinity. And then part D, we have an even root. Okay, so go back to the top. It says you want to exclude numbers that result in an even root of a negative number. So anything that's underneath the radical, if it's under a square root, it can't be a negative. So we would want to set this greater than or equal to 0. Okay, that would guarantee that it would not be a negative. So if I solve this, I would get 3, or divide by 3, I would get x is greater than or equal to negative 4. So as long as x is greater than or equal to negative 4, then those are the numbers that we would want to include in the domain. Okay, so I would say my domain bracket, because it can equal -4 to positive infinity. If we wrote that as set notation, it would be the set of all x such that x is greater than or equal to -4.